In the previous episode, we took a look at how the 2D VI can be done with the Boardmaster and how this can be useful when fault finding and diagnosing PCBs. In this week's episode, we will be taking a look at 3D VI and how this can be useful when looking in components in detail. So Oliver, can you explain 3D VI for us?
Absolutely. So last episode we talked about 2D VI, which as the name suggests is voltage against current. This time 3D VI, we're adding that extra axis, that z-axis to give us that 3D image, and that z-axis is frequency.
I see, so 2D VI we just have two axes, voltage and current. 3D VI we also have the frequency.
That's correct.
That's great. Can you show us an example of this?
Absolutely, yeah. So I'll bring up the 3D VI in the AMS module.
Yeah.
So once again, we're still on the AMS module. Start test using the foot switch. Okay, we're using the tweezers in this case. So I'll measure a capacitor because the resistor wouldn't show much variation in frequency. There we go, I can stop the test. And that's our 3D model of a capacitor's VI signature.
I see. So as you mentioned earlier, now that we have three axes, we have the frequency as well. As you're showing now, that means we could sweep across the whole range, the whole frequency range, showing us how the device responds depending on what frequency we're looking at.
That's right. So in our last episode, talked about 2D VI.
Yep.
I've got that right here. And in that case, we're stuck at a frequency. In this case, it's showing the 2D VI at 1 kilohertz.
Sure.
But in this case, it's taken lots of recordings from 1 kilohertz all the way to 5 kilohertz. That's what it looks like on the 3D model.
I see, so we can see how the device responds.
Yeah.
So for example, we may have a capacitor that's leaky at high frequencies, but it's completely fine at low frequencies. This could show us the variation.
Exactly. So if you're comparing two exactly the same capacitors, but one's leaking, one's not,
Sure.
you'll start to see it start to vary at different frequency.
Okay, and we can also do a comparison?
Yes, so VI is a comparison test. So looking at this, I won't really be able to tell what's wrong with it. So we need something to compare it against. I'll just store that signature. And then I can clear the mask. There we go, stored. Start the test, and I can just record this capacitor here. Start the test, foot switch. And then here we have our two different capacitors all on one plot. Here we use the tool here at the bottom to scroll through the frequencies. And you've got this handy little 2D map on the side, so we can see where it starts to look different. So in this case, at a high frequency, about 5 kilohertz, you can see that they're kind of similar, but then they start to vary a lot more at a low frequency.
That's great. So now we can use the results to compare the components against each other, or for example, a board against each other.
That's exactly right. So, you know, this isn't limited to the 2 pros, you can also use the edge connectors.
Great, and as indicated by the software, we get a pass or a fail.
Exactly. So this can be used by test flow. We'll get into that in a later episode. So here we have the blue mask is the first component I measured, and the thin orange line is the one I've just measured. All these colours can also be changed in the software. We'll get into that later.
And as we can see, the software gives you a pass or a fail depending on the results that have been obtained by the software.
Absolutely. So these are two different components. So obviously, they don't match, we're going to get a fail. But if they were the same component on two PCBs and they don't match, then you know that's a problem, and the software will flag that up as a fail.
That's great. Thank you, Oliver. So in next week's episode, stay tuned, where we'll be looking at how we can test ICs in circuit.